what has been the benefit of using just in time JIT instead of C bindings? Do you have a benefit in performance, or is about that you can't, or there are other benefits?
I think it's a good question. So if you just want the performance, you would write, for example, in different languages, like you can create a C extension even for Ruby to just make it fast. But I think the point is you are using Ruby because you want to write Ruby and make it more productive, make you more productive by writing Ruby. And so if you just want the performance, you write Ruby, you write C, but what Gcompiler allows you is you can just write Ruby and make it fast by just turning on the Gcompiler. So you can avoid losing the productivity by switching the language from Ruby to C or anything that supported by the extensions. So yeah, I think we often attempt to make optimizations that allow Ruby developers to not care about how it's implemented. Like I previously shared that the string concatenation can be faster if you use the smaller than operator. But if you have a Gcompiler that supports speeding up the other version, like the dot concat, then you don't need to worry about what is fast in this particular Ruby implementation. And so I want the Gcompiler to allow people to not worry about it and just be more productive by just writing whatever Ruby code they want to write. And so that's the vision, I think, of the speeding up the language itself, rather than asking people to write C.
Right, because with C you can only implement. I've seen part of the language implemented, right? So if you use this method, it's fast. If you use this other method, it's 10 times slower or whatever, right?
Yeah.
So it's kind of like all in or nothing, right? So with JIT, you can basically optimize across the board all the methods, right?
Yeah.
And then build up from there. Interesting. And what parallels have you found from the Haml optimization and the JIT compiler? What lessons were you able to translate from one experience to the other?
I think essentially for me, they look like the same thing. Like they are vastly different in the actual like structure, but I think the idea is the same. You have an input language, you convert that into whatever intermediate repetition you're comfortable or transforming, and then you convert that into, you first optimize that intermediate repetition you created for that particular implementation. And then after optimizing those intermediate repetition, you convert that into the output language. So in Haml, you take a Haml and parse that into the tree of the Haml nodes. And then that tree is then converted into a template engine language, template engine intermediate repetition. There's a gem called, Ruby gem called tempo.gem, and tempo.gem provides an intermediate repetition that's useful for implementing optimizing template engines. And so we use a tempo IR intermediate repetition as the output of the Haml tree, and then we then let the tempo gem generate the HTML string, the Ruby code to render the HTML string. And so the output is a Ruby code. And so sort of like the input is Haml, the tempo IR, and then optimize the IR, and then the Ruby code. What happens in the Gcompiler is, for example, in ZJ or YJ, you take the Ruby, and Ruby code is then parsed into the Ruby tree, like abstract syntax tree, and then the tree is then internally compiled into their interpreted representation called bytecode. Ruby virtual machine has its own original bytecode, Ruby virtual machine bytecode. And for ZJIT, the bytecode is the input. We translate the bytecode into ZJIT's own IR, and then it does the optimization on the IR and then output the machine code. So it's the bytecode is input, then converted into the IR, optimize the IR, and then output the machine code. So that way it's kind of similar essentially to me. So yeah, I think the similarities between those projects.